the square. You factor by completing the square when you're unable to factor. So this is just a method to get around factoring. So y is equal to x plus 4, x plus 4. And they call these perfect squares because your binomials are the same. What we will wind up doing is putting this x plus 4 together and squaring it. It's x plus 4 squared because x plus 4 times itself. And when we complete the square, this is significant to understand because we're going to take the square root of both sides to complete the square. So, if I have a problem like this, I just want to review really quickly before I proceed. This is the quadratic term, this is the linear term, and this is the constant. And what I want to do when I factor by completing the square is getting the constant on the opposite side as the rest of the equation. Minus 56 minus 56 equals that cancels. When you complete the square, you actually cut the coefficient of the linear term in half and then you square it. So and then you add it to both sides to keep the equation balanced. So I'm going to cut negative 30 in half, and I've got negative 15, and then I'm going to square it, and I'm going to do it to the opposite side as well. And now, negative 15 squared is 225, as we know. And when we combine negative 81 and 225, we get 144. And maybe you're starting to see where we're going with this. X squared minus 30x plus 225. Okay, so remember the process. Two sets of parentheses. Break up your x's. Look at the second sign. It's a positive. That means we either have two positives or two negatives. Look at this negative. Well, we have two negatives. What times what gives you 225 that adds up to 30? Well, that's 15. 15 and is equal to 144. So now we've got now we have a perfect square. So we've got x minus 15 squared is equal to 144. So we're going to take the square root on both sides. And the square root of x minus 15 squared, of course, is just x minus 15. A square root cancels out a square. So x minus 15 is equal to, the square root of 144 can be two values. So we're going to solve this twice. The square root of 144 is 12. And what's negative 12 times negative 12? 144. So x minus 15 is equal to, so did I say negative 144? What's negative 12 times negative 12? 144. So it can also be negative 12 under that square root sign. So we're going to add 15 to both sides, so we've got x is equal to 27, and we're going to add 15 to both sides, and we've got x is equal to 3. And we just completed the square, and we found our x-intercepts of our parabola. So when we see a quadratic equation, we're trying to figure out the x-intercepts. The first place our mind goes is trying to factor it. But we think about all the factors of 24, we try to make it add up to 14, we can't, so then we're going to go to completing the square. Okay, so I'm going to get my constant to the opposite side of the equals. I'm going to have x squared minus 14x is equal to negative 24, and now I'm going to cut the coefficient of my linear term in half and then square it. So we cut it in half and we have negative 7, and negative 7 squared is 49. So I have x squared minus 14x plus 49 is equal to negative 24 plus 49. Okay, so we have to keep the equation balanced. So since we added 49 here, we've got to add 49 here. And now we have a perfect square here. So we've got x minus 7, x minus 7, x minus 7. Okay, and then negative 24 and 49 is 25. And this is x minus 7 squared is equal to 25, square root of both sides. And x minus 7 is equal to two values. 5 times 5 is 25. And negative 5 times negative 5 is 25. So it's equal to negative 5. So now we've got x is equal to, add 7 to both sides and you wind up with 12. And add 7 to both sides and you wind up with 2. And we just found our x-intercepts of this quadratic equation. I should write it like this. It's 12. That's ordered pairs. It's preferable. So 12, 0. into 0, or x-intercepts. Thank you for watching, and the next will be the quadratic equation, another way of finding x-intercepts when you have a non-factorable quadratic equation.